This portion of this lecture is going to involve converting empirical formulas to molecular formulas. So we've discussed that there's a difference between empirical formulas and molecular formulas in that empirical formulas just represent the smallest ratio of the atoms in the molecule or the formula, depending on if it's ionic or covalent. And the molecular formula displays the actual amount of each atom present in the molecule. So therefore, in the case of peroxide, we saw that you can have a molecular formula that displays the actual amount of atoms in the molecule, or you can have the empirical formula that just displays the relative amounts. So obviously, if we're just converting from empirical formula to molecular formula, you just need to know what this formula is, and you would use some additional information such as the quantity of hydrogen and oxygen in terms of grams or moles found in like an unknown sample. So let's look at something like adipic acid. And adipic acid has the empirical formula of C3, H5, O2. Once told that we have a sample which is composed of 49% carbon. Let's see, I'm going to refresh this page. So this is the empirical formula, and this is adipic acid. And this would be a type of an organic acid, and the molar mass, so we have percent elemental composition, and we know that this corresponds to a molecular mass. And in this scenario, this is the information that's given to you. Now, essentially, we could assume that this percent is for an 100-gram sample. And then these values would then correspond to masses. So if we add the mass of each of these, we would see that based on the chemical formula, if we were to replace each of the elemental symbols with the atomic mass, for carbon we would place 12.011, for hydrogen 5 times 1.0079, and for oxygen 15.994. All of this would equal approximately 73.072. So now we have a difference in our molecular mass and our formula mass. So we can take the ratio of our formula mass and our molecular mass, and this will tell us what scale we need to amplify our formula to convert the empirical formula to a molecular formula. So simply put, the molecular formula should reflect the molecular mass. So I'm just carrying over the information from the other page. So we see that the molecular mass was 146.144 grams per mole. However, our formula mass was slightly less, significantly less, 73.072 grams per mole. So to calculate the difference in the formula mass and molecular mass, we can use an equation where N equals molecular mass divided by formula mass. And by solving for N, we can redistribute this N such that we take the empirical formula, and by redistributing the N, we convert to the molecular formula. So we need to solve for N. This process would take our empirical formula, which is C3H5O2, and convert it to C3NH5N O2N. Now once we identify what N is, we just substitute. So the question is, what's the difference? This, once divided, you'll find it's about a difference of 2. 146.144 divided by 73.072 grams per mole equals 2. So therefore, when N equals 2, we just replace the 2 here. So 3 times 2 is 6. 5 times 2 is 10. 0 times 2, 2 times 2 rather, is 4. So now we have the molecular formula. So this is very straightforward, and we can see that one of the requirements is that these values in the subscript location of our formula are integers. Therefore, when we scale it or when we multiply it by N, this must be an integer, and it must be positive. That way we have a whole number, and this allows us to convert from empirical formula to molecular formula. So this concludes the lecture.